I'm very excited about this because you saw his photo earlier and you heard him. So Filipe Santos is one of our colleagues here. He is a container solution architect and is someone who works with the rest of us here. So we're super excited to have you, and take it away.
We all dream of having the ability to have a piece of code that creates a Kubernetes cluster back to back, regardless of the underlying infrastructure. We have all the need to bring the application closer to our end users. We were told the cloud will fix it all, just like magic. I would like to welcome you all to the Kubernetes Dream by your dreamer, Filipe Santos. Over the past 18 years, I have been working my way up the IT ladder, from help desk agent to Linux sysadmin, to then cloud and container solution specialist and beyond. For the last 5 years, I've been focused on Kubernetes. This interest initially started with OpenShift, as I was an early adopter as of OpenShift 3.2 and up. And then it evolves to other flavors of Kubernetes, such as Rancher, kubeadm, KUPS, GKE, and others. The thing I hate the most is having to repeat a task for a second time in a row. For the past few years, if you took the opportunity to play around with Kubernetes clusters, you quickly realize that it wasn't that easy to create and implement a production-ready cluster. There are so many puzzle pieces that must be aligned in order to ensure the platform would behave as expected. We were then told not to worry, since the cloud will be solving all of our issues. Potentially, even a single click, and you'll be working on any cloud around the world. Soon to realize that it wouldn't be that simple. So we didn't give up, and we continued our learning curve, and found that Kubernetes on its own wasn't that easy. There's a lot of moving pieces that must be properly aligned to ensure you have a success story. From physical to virtual, how do you gain access to your cluster? How do you secure your platform, and so on? A few years ago, Docker, aka the fatty demon, made the container world known and approachable to us. Then came other container runtimes like Cryo, Podman, Containerd, and so on. A few moments later, OpenShift paved the way to container solution platforms into big organizations. Then we saw some companies attempting to deploy their own custom builds of Kubernetes, and others leveraging on orchestrators like kubeadm, KUPS, Rancher, and so on. At this point, some cloud providers realized that, hey, why not, and started to provide their own Kubernetes platform solution. What we are really looking for is being able to deploy a Kubernetes cluster over multi-regions on any cloud provider using the same set of templates, avoid vendor locking, and as a bonus, having a single view to manage them all. The idea would be to create an abstraction layer and to identify key components that are available on all cloud providers. The basic of a Kubernetes cluster architecture would be servers, storage, and load balancers. Then you'll decide on your Kubernetes platform. You'll create your set of templates and start having fun. You'll then need to decide on your automation language. Will you choose Pulumi, Terraform, Ansible, or something else? Then you'll ensure that you have a source control management configured and set up. Start committing. Embrace the fail fast approach and keep on improving. It's demo time. We made it. So on this session, we'll be focusing on creating two sets of server, one on AWS, the other one on Google Cloud. We'll deploy Rancher on both of them, and then we'll spin off a container with Rancher locally. We'll import the states, and we'll see what we can see from there. Stay tuned. Hello, everyone, and welcome to the demo session. So on this section, the first part, what we'll do is we'll start the build of virtual machines on AWS, and then automatically it will be deploying RKE and install some base packages within the cluster itself. So everything, as you guys will see, will be kickstarted or bootstrapped by a makefile. It's a cool way of automating, since you don't always know on what CI/CD platform your customer has. So a makefile is a good way so you can have a good ball rolling on your hand. In the meantime, while this infrastructure is being bootstrapped and created, I'll just give you an idea of what is exactly the make full build. What basically it does is going to make an initialize of Terraform plan. It will apply, then it will create a sleep, since there is a race condition between Terraform and AWS, and then it will automatically deploy Rancher and some default base packages as well on this end. As you guys could see, since I am using Terraform and the Mindset infrastructure as code, I am using mainly two modules that I have created. The first one that I called AWS Networking. This is really a Terraform module that contains everything related to the network, meaning the VPCs, the subnets, the gateways, the routes. And the other one, which is more for the, I called it a AWS RKE baseline. What that does is that it will generate the RKE templates, it will create them, the servers, the load balancers, everything that is required on this specific cloud to have a fully functional cluster on this end. So that will, here we go. So now the sleep is over, so now it's the process of installing Rancher on the servers. So this too will take a few minutes, so we'll fast forward this section and we'll take it from there. Here we go. So the first initial cluster is now officially set. Everything should be up and running and accessible. So as you guys could see, I was able to query the cluster to make sure the cluster is healthy, and everything replies healthy. All my etcds are health is set to true, so everything is beautiful in this sense. So the first phase of the demo is now completed. We were successfully able to deploy a set of servers using Terraform, templates generated by Terraform to automatically create the Rancher configuration file. We deployed Rancher, we installed Helm automatically, and some Prometheus and Grafana as well automatically on the cluster. So now second phase of the demo is we'll go ahead and install a second set of servers, but this time on Google Cloud, and this time we're using some simple bash script that I have created, and we'll go ahead and install the servers. Once the servers are installed, what will happen is we'll run a set of Ansible playbooks. Those playbooks will go ahead and configure the baseline, install Docker, and configure like the firewall D configuration that are required, and we'll go so on. Here we go. So as you guys could see, the servers are already up and running. What we'll do is we'll start the Ansible. Here we go. Whoa. Here we go. So basically, as you guys could see, infrastructure as code could be various things. You could use bash script if it's what is you're more comfortable with. You could use Terraform if you know. You could use Ansible. Basically, you have to use the tool that you're able and that you're comfortable with. You have to understand what you're running. You cannot just blindly and grab a code from the internet, copy it into your organization and execute it without even knowing what it does or how it does it. So this is why I'm saying I think it's the best approach if you're more comfortable with bash, or that you want to use the cloud provider CLI, use the tool that you actually know better at the moment, and then take the opportunity to learn other languages so that you can improve your knowledge and go from there. Oh yeah, so we generated the kubeconfig file. So in the meantime, right now it's best practice, since we installed a lot of features and kernels were updated, to recycle the hosts. It should take a few seconds. In the meantime, what we can go over is the configuration file that was generated by Ansible to deploy RKE or Rancher. So here we go. So I stored it over here. The RKE.yaml file. Here we go. So as you guys could see, I created everything was generated by blocks. So the first block is the initial configuration to install the server. So as you guys could see, the role that will be executed on this specific server, as you guys could see, it's a private IP, not a public IP address. On port 22, it's going to be the control plane of Kubernetes as well as etcd. The role is the master. And then what we have over here is afterwards, I have the three worker nodes that were defined. So as you guys could see, again, once again, it's using all private IPs. How to differentiate is the role over here that has been defined is worker. So worker means that there will not be any control plane that will be executed on those and running there. On this cluster, I did not configure it on my template the private registry. It was just to show you guys that you do not need to have a private registry. I just created a second set of template just so that for the purpose of this demo. But everything is as code. Everything was generated by Ansible. Nothing is hard-coded. So based on the amount of servers, you will be defining that Jinja template, which was used in backend, will automatically generate the script so that you can go ahead and whatever you want to bootstrap it from here. So what I'm going to do is I'm going to do R key up. And then I'm going to point to the configuration file. In this case, it's over here. And the configuration that we just saw is this rkey.yaml file. There's nothing else to it. All my configuration, everything has been done there, and everything is as code. So basically what it's going to go now is the same process as earlier on AWS. However, AWS was fully automated with the makefile. Here I didn't automate it. I would like to show you guys how simple it is to initiate this type of configuration. And as you guys can see, what's important is that everything is as code. So all the template, all the configuration, all my cluster, which nodes, how many nodes I have, what packages have to be installed automatically, everything is as code, part of my template. So this is what's important, that if ever you do have a failure somewhere in your data center, or that your entire region goes down, you want to know and you want to rebuild somewhere else, that you do have all the data required so that you can respin your infrastructure somewhere else on another cloud, another country, or just a simple another data center. So that will take a few minutes. I'll get back to you guys as soon as it is completed. Here we go. So cluster is up and running. I just did a few queries, entered the information in my etcd host so I can access the Grafana down the road, which have a quick view on Google Cloud. As you guys could see, the machines that we created are up and running. This is not a GKE cluster. As you guys could see over here, if I go into cluster, it is empty, so I need to go into compute and have a look at my instances. What we'll have a look is we'll have a look over here. Other type of information. Example, I want to go look more at the cluster. What's the total health of my cluster? This is a more overview. There's millions of dashboards that you guys could go look. If you don't know about Grafana and Prometheus Stack, just look it up. It's really worth it if you haven't. So this is what we have achieved so far. So now that we do have both set of clusters up and running, let's go ahead, let's deploy Rancher, and let's import the cluster so that we can have finally a single pane of view to see everything what's going on. What we'll do is we'll go ahead and access the Bastion server, and we'll just see if anything is running here. As you guys can see, there is nothing running on my server. So what I'll do is I'll just paste in the command. And this what we'll do is we'll retrieve the from the public cloud the official image for Docker for Rancher. It will spin it off on one of my containers, and then I'll be able to access it via the user interface. Here we go. So the first time you do access it, it's going to ask you to set a password. Set a password that you would like. And once you're happy with your password, hit you agree and continue. Like to use, in my case, since I do not have a DNS server currently with me, what I'll keep is the public IP of my Bastion server. So I'll just save the URL. And here we go. So this is the initial view of what you'd see the first time you do get to your Rancher UI. As you guys could see, I don't have any clusters, so what we'll have to do from now is we'll click on the button to add the clusters. And, what we'll do is we'll kickstart and we'll add a Google cluster. We'll create one. Why not? You know, so we could create an AKS cluster, an EKS, custom one. We'll start the ball by creating our own Google GKE cluster managed by Rancher. As you guys could see over here, what we'll do is we'll call it as a name. So we'll call it a fully managed GKE. Here we go. So that is the name of my cluster. Accesses over here, I'll leave it all as default for now. What I'm going to do is I'm going to read from file. Here we go. And what we'll do is we'll take one like that. That is perfect for now. Here we go. Now you do have all of the basic information. Do you want a zonal, regional? I'll go for regional. will remain in North America for now. Which version? I'm limited on the versions that I can select, but it's okay. I'll take the latest that is available on GKE, which is 169 at this current moment. Do I want some enable alpha features, stack driver logging? Do you want the dashboard? Yes or no? Pod auto scaling is enabled by default. So I would recommend leaving this there. If you want to enable or disable some other features, be my guest. I'll leave it as basic for now. I'll just spin this down to node count 1. That means that I will have one node per zone since it's a regional. I'll leave it as the basic over here. The default information. I'll enable auto repair. This is good to enable. It means that if ever your node becomes unresponsive, Google will attempt to repair the node automatically, and if it will not, it will spin off a new node for you instead. I will enable auto scaling. As you guys can see, the minimum node count is 1, maximum node count, I don't need 5, we'll put like 3 per zone, and we'll leave it like that. So what we'll do is we'll hit create. And once that is done, as you guys could see, it is now provisioning. So what we'll do now is we'll focus on importing the other clusters that we have achieved so far. So what I'm going to be doing now is I will click on add cluster, import an existing cluster this time. And what we'll be selecting is we'll name it over here. So what we'll do is we'll see this is RKE on GCP. Well, let's RKE on GCP. Member role, admin, it's okay for me, no enables that are required at this time. Here we go. So now it's going to give you some information. So what I'm going to do is I'm going to click on copy this link over here on the Bastion server. One thing that I will be doing now is I will be exporting my kubeconfig files. So kubeconfig equals, and it's at /temp config, so it's easier, so I do not have to specify it every single time. If I do like that, here we go. So the first step has been successfully created, and the second step, we'll copy the link over here, and we'll go on this end, and we'll press enter. Awesome. Perfect. So at this point, we have to wait a few seconds. Now it's refreshing. So what I'm going to do, here we go. We're going to proceed anyways. Here we go. So now if you go back to global, as you guys could see, oh, look at that. Oh, both are active already. Oh, wow, that was fast. As you guys could see, we created one that's called RKE fully manages GKE, which is kind of cool. As you guys could see, like I click on it, I have like basic metrics of what's going on, the state of my cluster, if there's any events, anything else, and there's all kinds of other information that is there available. If I want to use, there's like a kubectl configuration. I have access to my kubeconfig file. I have all the information that I currently need automatically. And now if you go back, if you recall a few seconds ago, I displayed to you that there was no Kubernetes engine. So now if I go back to Kubernetes engine, here we go. So one is created now, and is the cluster that was created by Rancher, which is awesome. So that's the first success story. And now, as you guys saw, I just imported another cluster, and this is the one that we called RKE GCP. And this is the cluster that has 4 working nodes. Is there any events? There is no major events. Everything looks normal. My memory, the cluster is really idle at this moment. Well, if you go back, we do have a bit more metrics available from Prometheus as well. So this is kind of cool. So now, as you guys saw, I was able to import clusters that were not even created by Rancher, that were like created as code and then imported into a single pane of view. From this point, a lot of features are available by Rancher. You can have access to tools. So if ever you do want, you could go ahead and install Istio. Automatically, you select the server that you want. In this case, since it's RKE GCP that is selected, it is on that one that it will be deployed. The version of Istio that is currently available on now if you go back to the cluster, you have access. If you go back to nodes, you have a currently all the views. If I switch to the other cluster, that is the one that is managed by GKE, as you guys could see the version, you have an overview of what's going on. If you want to edit your cluster, you'll be able to. You could go ahead and change some dependencies. On my end, I don't want because I'm as code. And you could launch the kubectl, which is like a CLI on the web, and you'll be able to interact with your cluster. Example, if you do a kubectl get nodes, here we go. I do have a reply. If I do a kubectl get pods minus capital A, I do get all the pods that are running inside my cluster. So this is something really cool, and that provides you a quick overview. So if you want to have someone have access to read-only of all your clusters, there's a lot of options available. This is one of them that you can fully manage and deploy as well, other features. So this is all I have for you guys. Hope you like it. If you have some questions, don't be shy to ask. I'll attempt to answer them as best of my knowledge. Thanks again for listening, and have yourself an awesome day. Thank you.
Hey, thank you, Filipe, for this great talk and this on Kubernetes, and at the same time, a bit of an overview of what Venture was. So that was really awesome. Now, I do have a couple of questions that came in from you. So like the first one, as a dreamer, what would you say are the 3 main ingredients that can help someone realize their Kubernetes dream?
I think the first step is to really put down on paper what your really end goal is. That avoids a lot of refactoring, and that you have a bigger picture out of the get-go of what you're trying to achieve. I think the second thing is try to go as code, infrastructure as code as much as possible. This will avoid a lot of headaches, because what we often see is that some customers start as code and then they start modifying little values here and there by hand. And this causes some, whenever there's a failure, that's going to happen, because we all know in the area of today, clusters don't live forever. They go up and down. So you're going to see discrepancies there. So going as code as much as possible. And this third thing for me, which is the most important, is the fail fast, meaning that you have to embrace failure. It's part of our journey today. So it's not because you decided or that you set your mind in a specific product or solution that it's going to be the right one. So fail fast approach, meaning that you're able to test that service. If it doesn't fit your need, don't tweak it to make it fit, because maybe on the next release it won't work. So drop it and look for something else. This will be like my 3 main concerns or tips I can give you guys on this end.
Thanks for that. In your demo, you have shown us 2 different deployment. Would it be possible to have only one of them, or have to be vendor specific?
Yeah, that's a good question. So what we realized today, and what I was open to realize, is that since there is no standard across any cloud provider, meaning that if you want to spin off a server on AWS or on Azure or on Google Cloud, it's going to be all different codes that you're going to have to create. So for the infrastructure part of it, you're going to have no choice than to create a separate one. However, what we could do is use the same templates for what's on top of it. And this is where Rancher comes and helps out a lot, is because it does abstraction of where it runs. It doesn't care on what operating system is underlying. It could be on, if you prefer Linux Red Hat, it's going to run on Linux. If you prefer like CentOS, Ubuntu, Debian, it runs on Linux basically. Also, some worker nodes could run on Windows for specific workloads that have to be there. So for the infrastructure part, you have to be specific for a specific cloud provider. But when it gets to Kubernetes cluster, this is the beauty, is that you can have one set of templates that will work on all the cloud providers, including on-premises as well.
All right, thanks. And one last question: if you have elected to select to install Prometheus and Grafana from the get-go in your script, could you walk us through the reasoning of that?
Yes. In my opinion, often when a cluster is spinned off, there is a lack of monitoring and observability to see what's going on really inside your cluster. And I think by putting those in by default, it provides you out of the box a view of what's going on and the health of your cluster as well. Also, the beauty of that is that in Rancher, what I wanted to demonstrate with that is that in Rancher, there's an add-on feature, meaning that you're allowed to create some baseline. So if you do have some proprietary tools internally to your organizations that have to be there by default, either the security tools or any other tools that have to be there by the get-go, you can include them in the add-on section and they will be automatically deployed into each and every single cluster. As for Prometheus and Grafana, it was just also for testing purposes to demonstrate that it's possible as code to have a cluster deployed on any cloud provider and have a set of application or services automatically available to you.